sort of what are the feel of it to be able to have everybody be comfortable. So there's going to be some new information, some information that people who know Python well will, they'll just be very simple, and then other information that you may not know about. So we'll go through some of it, and it starts off fairly general. So I want to talk about the office of the NetEdge. So Brian and I were talking about a little bit. Brian sort of got a preview in the other room of some of the stuff I'm going to talk about here. But basically, I come from a NetEdge background. So this is my first SE gig actually at Juniper. I come from NetEdge all the way back before that. So I love the command line. I'm a CLI guy, this is pretty much what I like to do, right? I like to think about complex network planning. I find that interesting and fun. I love moving bits. A lot of my time, when people are wondering what is it you're doing all day, if the network is up and running, then what? And a lot of it's, firefighting, etc. I like to do that as well. Then these last three things are sort of what's coming. And so what is coming? Well, what we've got in Silicon Valley is buzzwords, and the buzzword of the day is DevOps, as everybody's heard before, right? DevOps, what is DevOps, and all this type of nonsense. So 10 years ago, your Linux guy, forget about NetEdge for a second, but your Linux guy basically knew Linux. He knew probably a little bit of Bash, maybe a little bit of Perl, but that's probably about it. So what did he do all day? Well, Linux was kind of not so great. The kernels were pretty brutal back in 2.1 and 2.2. And Apache was terrible. There were so many issues that were out there that on a reasonably large scale, anything like 50 servers or more, basically your ops guy was doing black magic. Whatever it took to keep the site up and running, that's what they were doing. And then along came DevOps about 5 years ago, was sort of the very early adopters. And now it's pretty mainstream where if you're interviewing for tech ops, they're going to have you code something on a board probably. They're not expecting you to reverse a binary tree in C like you're a software developer. No, because that's not your exact skill set. You're more of a hacker, right? So the tail end of DevOps is going to be NetEdge. A lot of what we do is black magic to a lot of different people, right? So you have a hardcore guy who knows just about everything there is to know about a computer system, and then you say, all right, well, explain to me how you can get to Google from your machine. They will skip over every piece of the network. Well, I send a request to Google. Whoa, wait a minute, back up. How does that happen? And a lot of them just have no idea, and that's fine. That's our job. But the long and short of it is DevOps is here to stay, and it's bleeding all the way into our jobs as NetEdge. Generally, the industry that I see in Silicon Valley that's going to end up bleeding just about everywhere is going to be either one of two things or both. The command line will stay, but as you grow, you're going to want automation for just about every piece of your network and or a single pane of glass for your entire network. So there's two sides, right? A super pretty, really interesting GUI, and then on the other side, you basically have, it's code, but I can hit 1,200 devices at once type of deal. And so that's where we have network automation come in. And the bottom one. Some people will argue with this, and that's fine. It's whatever language you're comfortable with. A programming language is a programming language. Python just happens to be super readable and general and multi-purpose. That's why it's tended to be the choice in Silicon Valley. Again, this just sort of harps on what I said before. You do not have to be a programmer to be successful in automation. You do not need to be a hardcore software developer, not even close. And in our most simple of terms, especially for networking, basically you're just manipulating data. You're just doing string calculations. If you're getting this particular interface and you want to match it against that, and then do these set of conditions beneath it. So it's pretty simple stuff with what we're doing. And then as far as the core concepts of data types and how to manipulate them, again, all of this you already do all of this in networking by default, but sort of the next step is what is the language that you do around those. So this is actually a programming language. It's interesting. Someone actually wrote it. It is called Arnold. And that is the actual language. This is not a joke. This is a real program that will run. And the runtime is, it's showtime. That's the first statement. Then, because I'm going to say please, A. Talk to the hand, blah, blah, blah. Okay, so what is all this, what is this actually doing? And the reason I bring this up is, when people see programming languages, a lot of times they're intimidated by, I don't know, curly braces or white space count, in particular Python, and things of that nature. They're going, but what is all this? And the answer is, it's just this. It's the exact same thing. It's basically going through these individual lines, and some of it's just standard syntax, and other part of it is syntactic sugar, as in things that actually make programming language easier to read. This is actually a ton of syntactic sugar, but it's showtime initiates the program. This is like, if you've ever seen a C program like int main or whatever, that's int main. It just says, hey, wake up, this is gonna run. Because I'm going to say please. Because I'm going to say please declares a variable. That's all it does. So in other words, another programming language would be var a, or int var a, or var int a, or depending on what programming language that declares a variable. Talk to the hand, a is true. That's print. That's it. Print a is true. Bullshit. That is if. Talk to the hand, a is not true. It's actually, this is technically basically else. And then you have no respect for logic, which is the end if, or it closes the if statement. And then you have terminated, kills the program. This program prints out a is true. Does that make sense? So in other words, programming is actually pretty simple stuff. I know this looks crazy, and that's sort of the idea. Is basically like the syntax is just it doesn't take as long as you think it does to learn in a language, right? I mean, it's mostly in English. A for loop is a for loop. Declaring a variable is declaring a variable. A while loop is a while loop. A conditional is a conditional. All of these exist.
Does that stick around in RLC? The while loop?
Sorry?
Put in stick around. You remember that from
I can't remember. No. If you actually go to this page, it will give you all of the keywords and their corresponding what does this do.
That's fun.
Yeah, and there are while loops, there are for loops, there's almost everything in this. It's incredible. I think the actual underlying is written in Scala or something like that. This is where Python comes in as far as Juniper is concerned. We have a framework called PyEZ, and it's able to interact with a number of different things. The first one is a Python shell. So if you just type Python, or in my particular case, I actually don't like using that. I like IPython because I think it's a prettier shell. And you can basically interactively program. So if you're familiar with some languages like C or Java or something like that, generally these are going to be either they have to run inside of a virtual machine, or in C's case, it has to be compiled. Python is interpreted. Therefore, you can actually, you can see what's going to happen with your program as you type the program out, if that makes sense. Then you can also move to a Python script, obviously script everything out, into an IT framework, Ansible, Puppet, Chef, Salt. We support all those, by the way. And then do a custom application. So this framework will plug into just about everything. It is open source. It is on GitHub. It's from Juniper. Again, this is sort of the benefit. It's got native Python types. And there's no XML specifically required. Whereas when you go to a netcont transport, this is an open standard. This is an IETF standard for how you configure a router. This will work on almost anything that supports netcont. I think both Cisco and Arista do this. The difference is there's no abstraction, so you need to know all of the XML that's coming out. Now in Juniper, you can actually do show pipe display XML RPC, in which case you can get your XML, but it's still kind of a pain. Because there's no, it comes out as XML. You have to parse all that. I mean, it doesn't come pretty. So you sort of have to write almost your own micro framework around what you're doing. So that's why it's a layered approach. So we do have a number of configuration options Obviously, the big four are up there. They've all been in there, especially for the QFX lineup. I think 13.2 and after with enhanced automation. Every single one of those is going to be available. Today in particular, we're going to talk about PyEZ. So this is the abstraction layer for netcon. So basically, a Python library to interact with the XML API over SSH. It's not over port 22 SSH. It's over netcon SSH, which is 830. I think it's 830.
830.
Yeah. And the Junos API is XML driven. Again, it's basically saying, look, why would you process your own XML when we're doing it for you? It just doesn't make sense. It's also extensible in that way, which Jorge actually did the other day, in saying, if there's a feature you see that you're like, hey, why can't I do this? And it's like, oh, I don't know. It's one of the I think we're up to 98% coverage for PyEZ. You can do almost everything. But if you find one of those 1 to 2% that you can't do, it's just XML. Extending the library is 2 seconds. Also, the guy who maintains this on GitHub is super responsive. So pull request, any of that type of jazz. Or I'll do it. I don't care. So here's how we basically install Python frameworks. So again, like I said, I'm coming from the angle that some people have never actually programmed in Python. I think we have someone coming in.
Yeah, we got Simon and Willie. Come in, guys. Sorry. Yeah. Sound good?
You're just at the technical part.
You guys want some food? All right, Uber.
So you have to stay at the end because I have to feed you Juniper stuff so that you can get indoctrinated. No. So basically, again, I'm coming from this from the standpoint where some people know Python and some people don't. So I pretty much started from the beginning. Installing pip. Pip is just the Python package manager. And generally speaking, on any given system, you're going to be able to install pip by literally doing easy_install pip. That's pretty much that's pretty much available on every system that has Python installed on it. So Linux, Mac, and then for Windows, there is a bit of a different setup, which actually Jeff brought to my attention. With SIGWin, you should be able to mitigate a tremendous amount of differences, but it behaves reasonably okay.
So if you just install Python on Windows,
Yep.
Almost all the Pythons now that are pips included. You don't have to do anything. So you already have pip, and then you can just do pip install.
Sure.
Easy to see.
That's good.
Sort of. Except I ran into a couple of problems. But yeah. What can you expect?
You know what? If you're doing Windows and you're doing Python, you're just.
I got it to work.
You're just.
I totally got it to work.
You're on an experimental track, and I wish you the best of luck. Yeah, and if it's not on there, please install Python for 7. So here's how you would install the Python, the framework pip install goo.gl, which is, if you're curious what that is, it's Junos, the easy netconf client. You can optionally install IPython, which I'll end up showing when I go through a little bit of the code. IPython is just a wrapper around the Python shell that makes it look prettier. I'll show you the difference. But I actually think it makes Python a lot easier to work with. The biggest reason is it does tab completion. So if you can't figure out what your method is doing, like something dot, and then you don't know what's next or what your options are, when you hit tab, it'll actually list out your options. So it's pretty cool. Yes.
I'll throw in their Notepad++.
Sorry.
There's a program out there, Notepad++.
Okay.
You throw in Python on there.
Yep.
Because it has all the different languages. You start typing in Python, it'll tell you completions and stuff.
Oh yeah, autocomplete. Oh sure, there are tons of IDEs for that as well, definitely. But unless you're writing big scripts, usually a lot of us are just going through the Python shell at first, just to figure out what's going on. Okay, so this is actually this is one of the imperative parts about how you actually get these things to work. This is not turned on by default.
It's just way too complicated. What's wrong with Palo Alto?
I don't know.
I don't know.
That'll be the next one.
Sorry about that, late.
So for setting up your particular Junos device, and this is pretty much, this is Junos agnostic, set system services netconf SSH. I always recommend using the SSH bit, and then doing commit, which will open up TCP port 830. So anything that you want to use this automation framework on, that will need to be up and running. Yeah. Okay. So from this point, basically, when I have these code examples, what's happening at the end here is what happens for the last bit of code. So this is sort of, I'll walk through this. So we need to open up a connection to our device. We actually even need to define that we have a device. Is there anybody in here who actually doesn't code?
I know.
Okay, that's great. So one of the things that we do when we type Python, it opens up the interpreter, right? And then we're actually doing from jnpr.junos. We installed that in the last slide, right? When we did pip install PyEZ, we want to import device. So what does this do? All it does is bring me the device class. So it brings me a set of methods and functions that I can call from this device class. That's all that's doing. It's like an import in any language out there. Just call something in so that you're able to use the classes. And a class is just a big set of code. Just like, as we all know with machines, machines are inherently stupid. They don't understand anything. So when you get up in the morning and you say, okay, what's the first thing you do, right? Well, if you ask someone that question, what is the first thing you do when you get up in the morning? You would never think to say, well, I open my eyes, and then while breathing, I take the covers off me, and then I sort of sit up, groggy, and then I raise my hands to my eyes. I mean, that's like, if you'd be staring at someone blank-faced, you're like, why are you telling me all this? I didn't ask you all that, that's crazy. Now, a computer system, on the other hand, actually needs to know every single step of this. That's why we have to define every single little thing when we're coding. So the next one is we actually have to say that we even have a device, right? So what we're going to do is we're going to assign a variable called myDev. It can be any variable you want it to be. myDev, and we're going to set it equal to device. Remember, we imported this. We imported the device class in here. And we're going to say, give it some arguments, right? The argument is going to be, the first argument right here is going to be string argument. And that's going to be obviously the IP address of the device. The second argument is going to be user equals Dave, which is me. And then the password is Juniper123, which, by the way, this is a horrible way of doing this, super insecure. We'll go through the secure methods in a second, but it just makes more sense to show the default way. And then from that point, even though we've got this, we haven't actually done anything with it yet. We've simply defined a myDev that has all of these things set. Then at that point, we call mydev.open. MyDev.open opens a connection to your device. So now the netconf client is open. Now, if you typed in your username or password wrong, you would know, because it would throw an error somewhere around here. But since it didn't throw an error, right, in mydev.open, out, device, and now you know you're all set and connected. If it did not connect, it would throw an error. The in-out on there, again, I'm using the IPython shell for this, so that you can understand. It's just, it shows it off a bit better. Does anybody actually want to see this? Like me actually type this stuff into a shell? Would it make sense? No? Okay. So it does make sense what I'm doing here? Okay, great. By the way, I'll email everybody this deck afterwards. So, it's easy. Although, yeah, that's a problem, sorry. Don't copy and paste direct. So my ticks here, that is not a tick. That is something else. Yeah, oops. So just an FYI. I think that's the only one. This is going to be a bit more secure way to connect. So if you're in your shell, right, before you're in your Python shell, if you're in your regular shell, your bash shell. Another way to do this is to export your password into a variable, right? So my SSH password equals, and then in quotes, whatever your password would be. So this is another way, this is another way you can actually do it. And the reason is because if someone looks in memory of your Python script, I know that this is paranoid, but you know, we live in a NSA age. If someone looks in memory in your script, they're actually going to be able to see your password. Whereas if you export your password directly to your shell, that actually doesn't live in memory. That lives only in your shell, so they actually have to hack your specific account. So it's pretty great. Now that we've set up the connection, basically the exact same ways we previously did, right? Type Python or whatever we want to do, and the thing is, now we're going to import OS. So OS is just, again, a class that we're going to import from the standard library of Python. And the reason we want to import OS is because now we can assign this SSH pass variable to the OS environment of SSH my password. So in other words, we're assigning SSH pass to that. But we're doing it without ever actually specifying our password in the script. Does that make sense? A bit more secure. And then at that point, we do the same thing we did last time, right? My dev, blah, 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 but the password is set to SSH pass, which is the variable, and then we open up the connection. Is there any questions, by the way? Let me know if I'm going too fast or too slow. The third way, obviously, this is going to be the most secure. So this is the way you would end up doing it via SSH key, right? So there you go. I mean, it's basically the same type of deal. Same stuff, but instead of here, you can use user password, and then this password would be the password to your SSH key if you had one. And then you could have your private key file and it being whatever your private key file is. Does that all make sense? Okay. So again, spending a lot of time on how to actually set up the connection here, but this is actually pretty important stuff because this is the way I would recommend doing it. First of all, keys for everything, no matter what, if you can get away with it. And then second off, making sure that your passwords are never actually stored in your scripts, just as environment variables. Something of this nature. So the next thing we want to do is, okay, now that we have this open connection, right? We have this open connection, what can we do with it? What we can do with it is first we want to grab something so that we can print things out in a pretty manner. There is a print function that's built in, it's not pretty. It prints things all right next to each other. Pretty print, or pprint, that's actually what it's called. Pretty print prints things out so that we can see things and they're cuter. Let's put it that way. It's just, it's more readable. So if we type prettyprint dev.facts, what it's going to end up doing is going to spit out sort of a big list of facts that are going to be comma separated, colon separated, and each one of them is going to have sort of a key and a value. Is everybody familiar with dictionaries or hashes? Just key value stores, right? A colon 1. So A is the key, 1 is the value. If you call A, you'll get 1. If you call 1, you'll get A. Does that make sense? Right. Keys and values. So you're going to get a big bunch of key values from my dev.facts. The facts are basically what is going on with your device. Usually it's a serial number and routing engine and version of Junos and uptime and things of this nature, right? Maybe we want to get a specific fact, like a serial number. Again, we do key values. So in this case, we do prettyprint my dev, so we already set this up. This is on my device. We'll use the facts attribute or method for this. And then in brackets, we'll end up calling out the string of serial number. And then we'll close the prettyprint. From that point, what ends up happening is right here, right? And then we actually get the string of what the serial number is of that particular device. Is that making sense to everybody? How we got that and why it's that way? Okay, great. Some attributes may change, like system uptime. Now, the thing is, some people may say, okay, but why would I have to refresh? I already have a connection open. Yes, you do, but our Python automation framework is, well, we like to consider it smart. We don't keep a direct open connection for every single command you get. So what we do is when we first log in, we grab a bunch of information, that way it's cached. So you can call it on your local machine and manipulate and get data from there. So in other words, if something has changed, you do need to refresh. One of the things that will always change is going to be your uptime. Does that make sense? The uptime is going to be the uptime from right when you made the connection, not any time afterwards. So, you know, if you call it right after uptime, it's going to be bang on. But if you refresh, then it's going to be bang on from that particular point in time. So if you have this connection open for 5 minutes, the uptime is going to be 5 minutes old. So that's why what happens in this particular one is we do a facts refresh, right? We call mydev.facts refresh. Then we pre-print out the facts from, let's say we want to grab RE0, and then under that we want to grab the uptime. This is just, all this would be is something, what's known as embedded. But from RE0, RE0 also obviously has multiple keys and values below that. We're going to call the uptime key on RE0. And from that, right, we're going to actually get the string of 5 days, 13 hours, 22 minutes, and 16 seconds. Is this all making sense? Does anybody want to see an interactive shell thing now? Call it out if you do, because I mean I have it set up if you need to. But I figured we could probably run through this faster. Okay, so this is a little bit more Python-y. Instead of just calling things that we've already gotten before, we're actually going to do some stuff. So the first thing we want to do is we want to import from Juniper.junos, right? We know that. Then the next class below is the op or operational class. The next port below is is the ETH port. We want to import, in particular, the Ethernet port table. And the reason we want to import the Ethernet port table from all the way here is we want to assign it a variable. We want ETHs to equal the ETH port table of my dev. Is this all making sense? Mm-hmm. So this is our connection to the device. Now we want to actually grab an Ethernet port table of that. Now we've got the ETHs. So now we can start manipulating ETHs. So now we go ETHs get, which basically goes to the device and says, all right, give me all the interfaces, let's go. Okay. The thing is, ETHs.get comes back in a table format. And so how do we end up going through that and figuring out what interface is what interface? First thing we do is we start with and declare a variable, x equals 0. We do that because we're going to count. And we say while x is less than the length of ETHs, okay, do something. What that means is, when we did ETHs.get, okay, how many interfaces do we get back? I don't know. I don't know, and neither do you. It could be 1, it could be 48, it could be, I don't know, maybe we're on a 9200 and we have just a ton of interfaces. 200 interfaces, we don't know. And so programmatically, we don't ever want to hard code anything, at least we try not to. So we want to deal with, abstractions. And again, this is pretty standard programming practice. But basically, while x is less than the length of the ETHs, right, which is 0 so far, so it's definitely less unless we got 0 ETHs. What I want to do is I want to print the interface, and then I want to get the key of x, which is, so right now it's 0. And then information, print ETHs x, items x, etc., x plus equals 1. Now, what does all this nonsense do? This is basically a while loop. It grabs every single interface and says, okay, I want you to print out this one line for every single interface that I loop through, and as soon as x has started to get past the number, as soon as x is greater than the number of interfaces I have, stop, because there's no more interfaces, so who cares? Does that all make sense, what we just did? So Gigi 0, 1, 2, 3, 4, 5, I want it printed out in a very particular manner. And so this should give you an idea. I actually will demo this real quick. Is that cool with everyone? Assuming I have it up and running, which I probably don't. So this is the, did everybody see? Mm-hmm. Okay. So this is the IPython shell. Whoops. We got this. I'm going to do the insecure way because it's fast. Oops. Right. Let's import something first. I did that on purpose, I swear. All right, so since we've got our Junos framework installed, we're actually going to call up the device object. And then after we have that device object, now we can actually make a device object. Right. Again, that weird tick that I was telling you about doesn't like that one. So now that we actually have the device, we can open it up. Yay, that worked. Live demos are always freaky, so I don't recommend them. So now that we have it actually open, what we want to do is we'll just start stepping through this, right? We'll grab this and we'll say, okay, give me that ETH port table. Give me the ETHs. Grab the ETHs. Now it's going to spit out to us, because this is IPython and it's really helpful, that this thing has 2 items, right? Now we're going to start a while loop so that we can actually print this out and see what happens. Everybody see what's going on there? All we're doing in this particular oh, yikes. That's ugly looking. But basically it says gigi 0 and gigi 01. So it's giving you the key values in the table format of just about every single attribute of this device. So the or the operational, it's up. This one is down. On this particular one, this is how many RX packets. There's your MAC address, RX bytes. The admin on this is up, so it's it's actually up. Whatever the MTU is, the fact that it's running is true. The link mode is full duplex, TX bytes, TX packets, and then if it's present, it's true. So all of these things are actually attributes that we can get from this. Now we haven't formatted this. This is it's looking very Pythonic right now. This is actually what is that? That's a gigantic array with a bunch of tuples inside of it or something. But the point of the matter is we can actually see what's going on in there. Now on the next slide, which I think is much prettier, if we do the exact same thing, but we add some formatting to our while loop, I wonder if you can see it better if I make this bigger. You see that better?
Yeah, that's better.
Okay, so we still did this. We still have our ETH port table, we still have our ETHs, we still have all that stuff. But instead of just spitting this nonsense out, saying, hey, just spit the item out and call it a day, which doesn't look very pretty, what we ended up doing here is basically some print formatting. Now this right here is basically, this is NetOps programming. This is what it is. You're never going to have to do crazy calculations, at least very rarely, when you're in NetEdge, right? You're not like mapping zip codes and having to use crazy linear algebra to try and figure out where the edges of various things are, like certain devs would have to, or do really weird GPS calculations, something like that. With us, most of the time it's string manipulation, right? A string is just it's just characters, just a sentence. A sentence is a string. Usually it's just strings. So with us, this is just string manipulation. So basically this just does, interface is, and then curly brace, interface curly brace is curly brace MAC, curly brace link mode curly brace. And all that is just placeholders for this little guy that we call the end of it, which is a format string. Well, not a format string, but a format method. And the format method says, all right, for the first curly brace, I want you to call the ETHs, the key of the ETH of X, which is going to be the actual name of the name of the interface. The second one I want you to call ETH_X, which is ETH0, because in most programming languages we start counting from 0 in our arrays. So the first item is 0, second item is 1, third item is 3. So then I want the whatever interface we're on. If we're on if we're on the first item, it's going to be 0. I want ETH0. I want the operational, which is either up or down. Then after that, I want the 0 MAC address. And then after that, I want the link mode. And so that's all I did. I just made a big giant print statement and said format it as follows. So this will work with 2 or 10,000 interfaces, and you can format it how you like. Does that make sense? Clear on that? Good stuff? Okay, great. Glad we're making progress. Let's see, where are we? Okay, so we're here next. So in this one, we're looking at the route table. And it looks really similar to what we just did, right? So instead of this, we're just calling, instead of X, I said R for routes, right? R is 0. Go through the route table and print it the way I've told you to print it. That's all it's doing. That's it. And the answer is, it says, I told it to do route : and then give me what the route is. And then I said print out via interface, right here, and then give me what that interface is, and then give me the protocol it's come from. So you could end up doing things like sifting through all these things and figuring out what, how many routes you've got internally as far as BGP, as far as OSPF, etc. Now, you can do that by default now, right? You know, show route BGP is going to give you all your BGP routes on a Junos table. But if you were to run this across, I don't know, 50,000 devices, or 100 devices, or 10 devices, it's going to be much faster. You can also do other, other Pythonic things, which is shove all this into a database, or keep statistics on it. You could have this run every 5 minutes, and you could say, hey, the routing table likes to fluctuate crazily, or whatever it may be. So there are actually valid reasons for doing a huge amount of this stuff. Again, if you're doing routes, I don't recommend doing this on your edge routers because you're going to get a huge number of responses back, at least 500,000. And if you do it on your RIB table, then you're going to get a few million. So good luck with the memory on that one. Does that make sense what we did there? Why it is that way and all that type of jazz? Okay, great. On this particular one, these were a little bit too long for the correct process of actually how to go through this, of actually updating your config. So I just put a couple of. This isn't a Juniper one, but this guy does such a great job of actually stepping you all the way through exactly how this is going and stepping you through every single command that I didn't want to rip his stuff off. So I just put it in there, and you can end up clicking on it. The long and short is, updating a config is actually pretty simple. So you can grab a snippet, you can load it up as a variable, open a connection to your device, you can actually do a config check before you do anything. Then you can then you can do a commit, and this also supports commit confirmed. So all set and ready to go with like pretty much all the standard Juniper things that you would imagine that you'd want to have. So like I said, there are ways to update configs. He is going to run you through a pretty standard one, which is like, okay, I have a static piece of code that I want to put in there. I think in particular he adds a user, something like that, which is a common one. We just talked about that actually.
Yeah, static route.
Sorry?
Static route. That's what he added.
On this one? Oh, maybe it's a static route.
I checked those yesterday.
You remember more than I do then. But regardless of what it is, it's basically a static piece of code. There are ways to do this incredibly dynamically, to the point where you can do thousands of devices all having very different, tons of similarities, but actually very different code inside. We won't go through it today, but I do have tons of links in here for where you can end up pursuing that next. And that is actually the next slide. So these are the advanced techniques. So the first one I'd like to look at is Jinja 2. So Jinja 2 is just templating. That's all it is. So you would end up building out a config, and then you can actually build for loops and while loops and conditionals inside of a Jinja template depending on what's going on. That way you can have a lot of your devices have similarities, like every device I have must run MPLS. However, depending on the device and where it is in the world, it will be very, very different MPLS. So maybe your MPLS stanza is static, but all the stuff inside of your MPLS stanza is very dynamic, and that's where Jinja 2 comes in. A The second one is Slacks, which I'm sure everyone knows about. I'm going to get in trouble, but I'm not a huge fan of this. It is built into Juniper's DNA. It's on-box scripting. So Slacks is a language that was, I don't remember where it was developed. Maybe it was Juniper. I'm not sure. But you can actually run scripts on box. So commit scripts, operational scripts, things of this nature. The most popular one of all time is if I have interface A and interface B and no dynamic routing, if interface A drops, I want everything automatically to default to B. I want to move my default route, swap it over. It's in our Juno scriptorium. You can see how to do it on there. We do have them. They're not going away. A lot of the major carriers have used these forever and ever and ever. I'm just in particular not a fan because, I don't know, I just don't like the language that much. But it does work really well. Some people love these. So that's Slips, or Slacks. This next one is PyEZ program configuration data loading. That is going to run you through Jinja 2. In fact, that's going to run you through almost beginner to advanced. It's a pretty long doc. Relatively speaking, it's only like 12 pages, so it's not that long. But it will run you through some really interesting things and definitely give you some deep dives into what you can do with Jinja and Python framework. The next part is Junos 14.2. As of 14.2, we have a full REST API on the box. Okay, well there you go. So most people should be pretty familiar with a REST API. I have some stuff at the end where I'll end up showing where to go for certain things. But 14.2 does have a full REST API. And yes, it will come in either, your choice, of XML or JSON. So it's pretty cool. That's pretty modern. We're moving pretty fast in that area. We know we needed to do it, so 14.2, there it is, a full REST API. So if you're not happy with our framework or you want to use some crazy language like Arnold or something like that, great, no problem. REST API should be able to provide you all the JSON you can handle, and in that case you can do what it is you like. So that's good stuff as far as advanced techniques.
Is that REST API a separate package that can be installed, or is it built into?
Built in. You literally type like I think it's one command to enable your REST API. And then kabam, you're done. It is awesome. I'll email you. I really like that one.
I mean, 14.2 is very advanced.
It is very advanced. I will grant you that. But you know, 6 months down the road, 14.2 could be the recommended code. You never know. I mean, right now I think we're almost across the board. We're at 13.2, 13.3 for everything, right? Almost across the board. Not for SRX. That's different.
Not even like my EX 2200 recommended 12.3 still.
It's a 22. Come on.
Just saying.
What are you running on that thing?
12.3, dude. It's like,
What are you running on that thing? I have 22. I run like 14 something on there.
you can run anything. I'm talking about recommended code.
Well, anyway, speaking of that, I might as well touch on that since I just stepped into a can of worms here. The recommended code, as far as Juniper is concerned, what we recommend is whatever meets your needs and doesn't exceed them. So what I mean is, if you don't need the feature right now, then don't use the code that supports it. If that makes it, going forward type of deal. The code that we have on our recommended page is simply lowest common denominator. That's all that is. But like for instance, if you were like, no, I require a REST API, you can actually contact your SE, but you can contact your SE or JTAG for that matter and say, hey, I need this REST API, I want to run it. What is the code you're going to recommend me run on these boxes? And they can actually give you some interesting ones. There are also, there are ones that you can't get from the page, and you know how it is. There's some special ones, etc.
So the controller is going to be constrained or something that's being developed?
Yeah, definitely. I would almost guarantee it's probably going to be Contrail. Which, by the way, for those of you who don't know, that's our SDN controller solution. Does not use OpenFlow. It actually is it's pretty awesome. It uses GRE tunneling, L3 VPNs, BGP to pass messages, route messages, and then to pass actual messages, the controller uses XMPP, so push-pull, both. I don't know, I like that. And it's also free to download, so hintity hint hint. So here's a bonus. This is zero-touch provisioning, so ZTP, or zero-touch provisioning, it allows you to set up a device without ever logging in. Our device is shipped with it on. It's actually rather annoying when you first log in because you have to turn it off if you're not doing it. But if you are doing it, it utilizes DHCP, obviously to get the address and send over the options, and then the transport methodology for your configuration file or your new image is either TFTP, FTP, or HTTP. And again, it's supported by default, but if it's not on for some random reason, I mean, I've never seen one where it doesn't come by default on, but if for some reason it's not working, you can always request system zeroize, and it comes back to default. DHCP requires option 43 to be set. What is option 43? It is a vendor-specific option. That's actually in the IETF mandate. Vendor-specific means the vendor can do whatever we want with it. So we did, and we ended up using it for ZTP. This will actually go through how to basically load it up. Software image configuration, automatic provisioning, etc. The sub-options in particular that I bothered to write down, 00 is the sub-option of 43. It's just going to be the name of your software image. 01, the name of the config file, and then 03 is going to be the transfer mode. 02 is something weird that we don't really use very often. It's whether it's a symlink or a hard file, but you usually don't need to know about that. And so from these, if you configure your DHCP server and your TFTP, FTP, or HTTP server, you can actually end up upgrading a device across the board without ever having touched your Juniper device, save to plug it in with power and one Ethernet cable. If I'm correct, this was used in a massive chain of stores, actually, right? I'm sure there's a bunch of them. So this definitely does work. It's pretty cool. And that's ZTP. So here's the next steps. This is important for every stage of Pythoner. The first one is if you want to learn Python, there's actually a site called codeacademy.com if you're not familiar with it. You can technically just go through Python and not even log in. They actually allow you to do that. You can run through everything, but it just won't remember where you are in the tracks. Other than that, you can log in. I think they make it crazily easy. You can create one, or Facebook, or Google, or just about anything. And this Python track, it is not hard. It will step you through every single little detail as if you've never programmed in your entire life. And by the end of it, you will easily be able to manipulate PyEZ. It's that simple. You'll easily be able to do it. You're not going to be a hardcore software engineer. No, you'll definitely have your feet wet. There's no question. This track is fully interactive. It's not like reading a bunch of book pages. No, you're coding the entire time. The first thing they have you do is write a print statement. And in browser, it actually does the Python in there. So every time you click run, you can see your code run and what you've done. It's really neat. That is a cool startup. So that is the place that I would recommend to everybody start to learn Python. Everybody wants to throw out all these other ones, but as NetEng, if you wanted to be a software engineer, you probably would be already. You know what I mean? I mean, you wouldn't have spent all this time learning all these crazy acronyms like OSPF and ISIS and BGP and all this other type of jazz. So this is more along the lines of, no, get me to hacker level. Get me to hacker level. I want to be able to manipulate some strings and do some data, and I want to understand the structure of programming language, but no, I do not need to write like my own app from friggin' scratch. And that's exactly what this guy's going to do for you. The second one is going to be the Python framework. It's just right there. Again, you can just do pip install PyEZ, and you're going to get it. So there's that. Another one that this actually debuted was it last week? When was Nanog? Last week, yeah. This actually debuted last week when I was at Nanog. That was pretty cool. So this is a multi-vendor API abstraction framework from Spotify. This will actually do Juniper, Cisco, Fortinet, and Arista. Now, naturally, you should only be using Juniper for obvious reasons. My boss is in the room. And so you know, but beyond that, no, this is actually quite a cool tool. It is, and it's something to know about. And Spotify is a reputable company, so it's something to take a look at.
Is it just for configuration or?
It doesn't support everything, but I actually think it ropes in the other frameworks as well, including ours. So it's sort of like an abstraction of the abstractions. And then, of course, here's the ZTP overview. So this is going to give you an understanding of what ZTP does and why it does it, etc. Yeah. So these are the next steps for anybody who'd like to continue on with things. Again, I will email this out, or Jorge will email this out. Someone will email this out, this deck out to everybody on the conference, so that way you can see where everything we've done on this. I'm trying to think. Anything else? Is there any questions? What's next? What's coming? What about Ruby? Stuff like that. Yes.
ZTP?
Yes.
It seems like only EX and MX files supports ZTP, so like
I don't think MX supports it.
MX, SRX supports it.
SRX definitely supports it. I know EX does, and I'm positive QFX does.
Yeah.
MX, I don't think.
I don't think MX supports it, but then again, do you really want to bootstrap your router like that? That freaks me out.
Got team members that was.
No, I'm just saying.
It's over that crazy stuff.
Maybe you do. We have customers down south, and they buy nothing but MXs. There's a customer who's bought like 40 of them last year. You know, obviously doing some heavy route stuff, but I mean, they might actually want that. So, I mean, whenever I hear a question like this, you know what my default answer is, because there's too many PLMs that I talk to. It's on the roadmap.
I'm 20. Someday.
Someday, yeah. I'm trying to think. That's the story from the PLM anyway. Yes.
So, do you know the PyEZ is a class say to put that into multiple threads so they can call the device in parallel, like multiple devices in parallel?
Yeah, you could do that. You could definitely do that. The only issue is that Python has a global lock, so it's going to be parallel but not concurrent, if that makes sense. If you use Go, you could do, you could spin up a ton of Go routines and you could hit 10,000 devices identically. But yeah, so with Python, I mean, you can definitely do it. I mean, there's no question, but you know, it's interpreted, right? So while you're going to be able to process across multi-cores, I'm not sure that you're going to be able to actually get multi-connections responding at the exact same time. Although it's possible. It is possible. There's other interpreters as well.
You might run out of memory at some point if you keep too many open connections. Yeah.
The other one would be that I would check on it. I'd check PyPy. You know PyPy? PyPy. Check that out. PyPy is a so we just ran Python, right? You guys all saw it, that IPython shell. That is running on what's known as a Python interpreter. There is more than one Python interpreter. The one we're using is called CPython. It's written in C. It's the main one. There's another one called PyPy, which does a JIT, or just-in-time compilation. JIT. Just-in-time compilation basically, it basically compiles it to machine code as it's running. So the first time running it is a little bit slow, and then the second time through, it's crazily fast. Does that make sense? Yeah. So it's py-py, and you can pip install that as well. It's just a different interpreter. That one's built for speed, a lot of speed, and it is 99.9% compatible with Python 2.7. So it's there. It's definitely there. Anything else? Questions, comments, concerns, etc.?